So today I'm going to be presenting a case study for an environmental offset, and why we called it novel is because we're going to look at different pollutants as the currency for trading for the same offset rather than looking at just one pollutant. Just to introduce the team a little bit, we have Meenakshi, Nathan, and Vincent Pettigrove, who are from University of Melbourne. And Vin is also the CEO of CAPM, which is an institute based out of University of Melbourne. And then David Feldman and Cameron are from University of California, Irvine. So this offset is the initiative led by Western Water, which is a water utility based out of Victoria. All right. So a couple disclaimers. This is not a modeling talk, and this is really a brand new project. We have been working on it for about 9 months. So, and it's an amalgamation of all the work that my co-authors have done. So I'll try to do a good job of representing what they've done. So EPA, which is the Environmental Protection Agency for Victoria, it sets the state's environmental protection policies, which allows offset as really the last resort for mitigating pollutants in a system. And this is after you have done all your efforts to avoid, reuse, treat, and dispose. But there's really very minimal guidance that's given on how to use an offset to meet the required regulatory compliances. And the language is pretty vague. It basically says that an offset should potentially cause a net environmental benefit, and in the worst case, really no net loss. So when Pettigrove's team at CAPM conducted a really successful offset in the Dandenong Creek near Melbourne, and they basically used multiple lines of evidence, and it was used as a viable alternative to upgrading a treatment plant. And this project saved Melbourne Water about $84 million. And that's when offset started gaining a little bit of popularity, and Western Water wanted to use the opportunity to test the current legislative and policy tools for environmental offset. And if this case study is successful, it can potentially be used more widely. Sorry. All right. Just to give you an idea of where we are geographically, this is the Jackson Creek case study that I'm going to be presenting today. And this is basically the greater Melbourne area. The city of Melbourne is right there, and the crescent-shaped water body that you're seeing right below the city of Melbourne is the Port Phillip Bay, and that's actually a really important ecological endpoint. There have been algal blooms recurring in the Port Phillip Bay in the recent past. So the case study that we are looking at is right upstream of the city of Melbourne. There are really two catchments that we're looking at. The one that I'm going to be talking about is the Gisborne-Jackson Creek. Just to give you a little bit of background, we have the Roslyn Reservoir that's just upstream of, or the headwater basically, for the Jackson Creek. The first town on Jackson Creek is Gisborne town, and then we have the Riddles Creek that's up here, and there's some population there. They both meet right up of Sunbury. And there's one treatment plant in the Gisborne area and one treatment plant in the Sunbury area. And both of these treatment plants discharge directly into the creek. So this area is within the 2050 Greater Melbourne Urbanization Plan. And in the next 20 years, actually by 2036, it's expected that the population would increase by 40%. So there would be quite a bit of urbanization in this catchment. And that basically implies that there would be increased inflows and outflows to the treatment plant. The treatment plant that we are going to be considering is the Gisborne treatment plant located right here. So all the population in the Riddles Creek area actually drains, or it's connected to the treatment plant in Gisborne. So Western Water runs this treatment plant, and the EPA has given directive to reduce the mixing zone. So mixing zone is basically the zone right below where the point discharge is. And to be able to do that, Western Water needs to upgrade the plant from a secondary treatment level to a tertiary treatment level. And this would cost them about $30 million. So Western Water has this goal of 100% beneficial use, and they have run recycled water schemes in the past. As a matter of fact, the plot that Ali just showed you, during the Millennium Drought, they were able to sell about 70% of the effluent. But now that the drought is over, the farmers have rainwater that they can use. It's gone down to 9 or 10%. So the regulations are really becoming extremely financially restrictive, and if they have to upgrade the plant, they would rather try to sell that recycled water rather than just dump it into the creek. The plot on the left side shows you the land use. So it's mostly pastoral at this point of time, and there's a lot of ag, followed by rural households and rural roads. There's some forested area way up on the top. So when we started looking at the case study, we tried identifying what are the main sources of environmental flow and pollutants into the Jackson's Creek. And we came up with 4 sources. So it's like non-point sources, which is just runoff that you get from residential areas. Then there's obviously the reservoir way up top. It's mandated to release about 8 million liters per day, but in most cases it releases about 5, and in some cases it releases even less. Then there is a significant agricultural runoff, and then obviously there's a point discharger, which is the Gisborne treatment plant. So if you consider the EPA directive, you would be only looking at an end-up-by focus, which is like right here, the mixing zone. Western Water wants to take like the whole stream health into account and consider if you can look into an offset or not. So this is to show you what happens in the Jackson Creek. The plot up top is basically the reservoir storage, and this is what Ali was talking about. This is the Millennium Drought right there. It's like about a 10-year period, and at that point of time, the storage was at 3% of the total reservoir, and what happens is the first thing to go is the environmental flow. And this is the release that you see. It falls down to almost nothing. And the interesting thing to see is like this is Jackson Creek flow right above the treatment plant. Even though the drought is over, the reservoir has just taken to releasing almost nothing. So it's relying a lot on the treatment plant, which releases about 16 million liters per day. So the objectives that we are looking at, we have 3 main directions. The first one is to assess the environmental values and pollution issues in Jackson Creek. We're going to try and identify key stressors that impact the health of the aquatic fauna, and also determine the relative contribution of the effluent to the Jackson Creek. There seems to be like this accepted knowledge that the effluent treatment plant is the culprit, and we want to see if that's really the case or not. The second scenario that I'm involved with mostly is basically developing models like watershed and in-stream models to establish the base condition and also run scenario analysis for future. The third one is the development of offsets. We haven't quite gone there yet. We are going to examine the strategies to minimize the impact of contaminants at a watershed level, and also qualitatively evaluate stakeholder surveys and try to introduce adaptive governance. And I should mention that Alluvium is a consulting firm that has been hired by Western Water to do that. All right, so this is from the literature, really, and this is just to show you how multidisciplinary and successful offset needs to be. So there are 5 key elements that you need to address if you need a successful offset. The first one, and the most important, is really institutional capacity. This looks at what are the existing policies, what are the regulations, what is the structure between the institutes that are involved in the offset, and if those institutes have enough resources, like both money and people, to actually run this offset or not. And Western Water has been doing a really great job of including everyone in this. And historically, I mean, that is the reason that many of the offsets, like, in the US have failed. The second one is where most of our research falls in. It's like equivalence. In this, you try to come up with the right kind of currency for a given offset. It could be like for like, which is you take one pollutant and you try to run an offset based on that. Or you can come up with like different kinds of pollutants, but somehow you have to like figure out what is the ratio or what is the equivalence between those pollutants. Additionality is basically it kind of ensures the integrity of the offset. In this, you try to add to the benefits that would not have occurred if not for this offset. Economic feasibility is again very, very important. It basically says it should be the cheapest option. And then social acceptability. The people should accept what is happening. They should not think the government is manipulating them, there's not enough transparency, and all stakeholders should feel represented. All right, so just to give you a concept of what are the threats and values, we have point source discharges. That's nutrients, sediment, toxics, and pharmaceuticals. The non-point discharges are like, there's just runoff, there's sediment, pesticide, herbicides, and metals. So platypus, especially female platypus, is considered one of the endpoint values, and the creek has seen a significant decline in the platypus population. And this is just one of the values. It's also seen a decline in the fish population. And then amenities is environmental flows. So CAPM basically ran multiple lines of evidence study for the assessment component of the case study. The first one was we grabbed a lot of samples from like sediment and water from about 6 or 8 sites over multiple sampling incidents, and we looked at pesticides, hydrocarbons, nutrients, heavy metals, E. coli, and any estrogenic compounds. We also did some toxicity studies, chironomids, amphipods like algae, and sediment toxicity. Then the next one is like biotic environmental stress. Is the toxic and the chemicals present causing any environmental stress? So we looked at like microinvertebrate assemblages, fish assemblages, and they have this, CAPM developed this alarm system which looks at, it's basically a bunched biosensor which constantly monitors DO, pH, and tries to see if the animals are responding to any change in the stream or not. The last one is aquatic fauna impairment. In this, we try to look at the effects of endocrine disrupting chemicals on invertebrates, mud snail, and short-lived fish. There were no long-living fish in the creek, actually, so they looked at mosquito fish. All right, so the modeling component, we looked at 2 different models. We used eWater, which is basically an accepted modeling platform. So we used music for setting the catchment delineation, and we used source for the basic rainfall runoff modeling. The modeling is really at its preliminary stage. We have just done the calibration. We just got the data last month. So we are looking at the reservoir outflow. We are assuming that it's either there's steady flow or there's no flow. Then we are trying to look at like normal and drought conditions. And then we assume there's always RWP or the treatment plant discharge. There's the base. The population would grow by 2036. It can either grow in Riddle's Creek catchment or in Jackson's Creek catchment. And then we assume that there might be some reduction in discharge just by less consumption, or they might be able to sell the water. So the last methodology is the social component. This is really the key focus of the project. And as I mentioned, Alluvium is conducting online surveys to do this, and Western Water is focusing a lot on transparent community engagement, and this is a typology of a paper that we recently got accepted for. In this, we basically talk about how depending on what you want, what your outcome is desirable, you try to put them in different groups. This is like process as a mean where you're constantly talking to the stakeholders and engaging them in the outcome. So just to present some results, do I have any time left? Oh, okay, good. Like I was rushing a little bit. So, okay, so just to show you the results, algal toxicity occurred at every site, both upstream and downstream of the treatment plant. So, the nutrient concentrations were high, and we saw like some biological impairments. And generally, the condition of the stream is pretty bad. So it's like, even though the RWP is adding some effluent, it's really not deteriorating badly. So this is my modeling result. The preliminary modeling is very consistent with the observed data. Again, we see elevated nutrient concentrations at all the nodes, but we're basically using a rainfall runoff modeling. We see less concentration upstream. It kind of goes down and increases. And some of the metals that we selected from the assessment study, they are going to be elevated. And if you run any scenario, it does not matter if you grow the population in Riddles Creek or whether you increase the population in Jackson Creek, the health of the stream is going to be pretty bad. So the assessment, we recently published this, and we are in this phase of the study where we are doing life cycle assessment. So the take-home message is the stream is in poor health. The treatment plant does add nutrients and some herbicides and EDCs into the system, but it's not deteriorating the health of the creek. It's actually adding to the flow, which is necessary to maintain the fauna in the creek. And the recommendations that we have suggested is we have to reduce the pollutants entering Jackson Creek from not only the RWP, we also have to introduce a bunch of pre-treatment in the stormwater if we need to. I'm done. This is my last slide. All right, so, and we also, we have to ensure sufficient flow, therefore we do need the treatment plant releasing the effluent into the creek. All right, thank you, and sorry for rushing.